Hi everyone, this is MK and this is another problem from LeetCode Daily Challenges. If this video have been suggested to you by YouTube, that means you probably like my videos. So please like and subscribe. I solve LeetCode Daily Challenges. I try to solve them every day, and the more follower I get, the more video I will create. Thank you. Okay. So today's problem is um we have solved a problem like this a few weeks ago, and that was the subarray sum to be less than k. So in this case, we have the product. Whenever you have some problem like this, let's read the problem first. Given an array of integer nums and an integer k, okay, return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. All right, so we should count all of the subarrays that their product is less than k strictly. So in this case, let's look at example 1. So k is 100. So we have 10 and we have 10. So one way of counting the number of subarrays is to count the ones that start from 10. So if you start at 10, you can end at 10, or you can end at 5. So there are two of them. So that would be 10. And that would be 10, 5. Okay. If you start at 5, you can end at 5, you can end at 2, and you can end at 6, because that would be 60. 5, 2, 6, 60. So there are three of them. So 2, 3, 5. Okay. And if you start at 2, you can end at 2, or you can end at 6. So another 2, that would be 7. And if you start at 6, you can only end at 6, and that is 8. So one way of counting the subarrays is always count the number. You can fix one end of your subarray and do something for the other end. We will talk about it. So first thing you should notice is how many subarrays do we have in general? How many of them? Let's go here. Let's say you have an array and you want to count the total number of subarrays. So if you want to do that, one way of counting them is to count all of the subarrays that start here. So if you start here, you can end anywhere, like here, 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 all the way up to here. So that would be n of them. So n plus. If you start here, you can end here, you can end here, and all the way up to here. So it's n minus 1 plus n minus 2 plus all the way to 1. So this is n times n plus 1 over 2. So and the running time of such an algorithm is O of n squared. And O of n squared is not good for the constraint that we have in this problem, that is 3 times 10 to the 4. And if you replace n with that number, so it's going to be 3 times 10 to the 4 to the 2. This is almost 10 to the 9. Almost 10 to the 9. And as a rule of thumb, whenever this number is close to 10 to the 9, that is probably not a good idea. That is probably, you should do better. You should look for a better algorithm, okay? But how do we solve this problem? So let's count all of the subarrays that start here. Just index 0. Just index 0. How do you count all of the subarrays that start at index 0? So one way of doing that is to get another pointer and keep extending this subarray. Extend it, and stop the moment that the product is greater than or equal to k. So if we stop at, let's say, index 8, that means we can start at 0 and we can end at 0. We can start at 0 and we can end at 1. All the way, and we can start at 0 and end at 7. So these are all of the subarrays that can start at 0 and their product is less than k. Why? Because this is the first time that product is greater than or equal to k. So that means up until 7, everything was good. All right. So as you can see, this is a window. This is a window. All right. And if you haven't guessed already, this is a sliding window problem because we are expanding from the right and then we are shrinking from the left. So after we stop at 8, we shrink the window just by 1 cell. So we do this. We say, okay, now I'm going to shrink it just by 1 cell. And now again, if you can expand it, keep expanding it. If you can expand it, like let's say, I'm going to expand a few more cells and let's say I stop at 10. That means I can start at 1, end at 1, start at 1, end at 2, start at 1, end at 3, start at 1, all the way up to start at 1 and end at 9. Not 10, 9. So that would be all of the subarrays that can start at 1. And we keep doing that. We expand, we shrink. We expand, we shrink. We expand as far as we can. We shrink only 1 cell. All right, let's go and write the code for this problem. So what we have some variable for the total number. So first, if k, so what is the, if we look at the second example, k is 0. So for k 0, the answer is always 0 because input is positive. And also for k1, if k is equal to 1, the answer is also 0. So if k is less than or equal to 1, return 0. That's it. That's it. Otherwise, we need some total count, which is 0. And then we need let left equal to 0, let right equals to 0, and let product equals to 1. All right. And while, and we need also const n. And while left is less than n, what we do is that we keep expanding. So while right is less than n and product times nums of right is less than k. Is less than k. If that is the case, we update product. So product is equal to times nums right. And then we move right 1 step forward. So right plus plus. That's it. So when we stop here, we should add right minus left to the answer. So if we go back to this example, so here, the first one, we stopped at 8. So 8 minus 0 is going to be 8. So that is the total number of subarrays starting at left. So total count plus equal right minus left. Now we move this, we shrink the sliding window by 1 cell. So product is going to be divided by nums left. And then we move left forward, left plus plus. That's it. And then in the next round, we are going to expand again and then add the total count and then shrink again. Expand, add the total count, shrink. Okay. And here we return total count. That's it. And we submit. All right. Thank you for watching and see you tomorrow.